Hello, this video is about a demonstration on the Phet simulator for gas laws, as well as how these gas laws relate to physics, specifically Newton's laws. So we have the constants on the side, and particles both heavy and light, or larger particles and smaller particles. The larger particles, as you can see, each come out separately, and the smaller particles will move at a lot faster rate than the smaller particles. That's because their size changes how quickly they move. Smaller, as you can see, moves faster, and larger moves a lot slower. Now for the constants, there's nothing, and when you have no constants, it means that you can change the temperature, heat, or cold, you can change the volume, and each of these will also change the pressure gauge on the side. So like the volume, smaller, pressure went up. The heat, as you heat the container, the particles get faster, and the pressure will also go up. And on the opposite side, if you cool it down, the temperature goes down, the particles slow down, and the pressure will go down. When you have the volume as a constant, you can change the heat, and again, the pressure will go up because particles are faster. When you change the heat, or when you lower the heat, make it cold, the particles will slow down, and the pressure will lower. On the other side, you can have more particles in the container, and that will also raise the pressure over time at a slower rate. For the temperature constant, you can now move the container, have a different volume, which will also change the pressure on the side. When you have a bigger volume and the same heat, that pressure will go down. And if you have a smaller volume with the same heat, the pressure will end up getting larger. Same with if you add more particles here, over time, the pressure will still keep going up. For the pressure to stay the same, while volume can change up or down, that will be dependent mostly on how many particles you have in the container and the heat, or how cold it is. As you can see, to keep the pressure the same, cooling it down will lower the volume, heating it up will expand the volume, and pressure for temperature is similar, except this time you will be able to change the volume of the container, and as you do, you can see down here, it'll either be colder temperature to keep the pressure the same, or you'll have a hotter temperature to keep the pressure the same, as well as adding particles or decreasing particles, like decreasing a heavy particle. You have it heat up so that all these particles move the same, or if you add more, it'll be cooler so that all the pressure stays the same and the particles are moving at the same rate. How all of this relates to Newton's law is we have 3 of his laws. The first one, as you can see, the different particles move in their different directions. That relates to Newton's first law, how something in rest will stay resting, or something in motion will keep being in motion unless there is an external force that is exerted upon them. In this case, these external forces that are moving them around are the other particles that they are bumping into. The other particles act as like different forces that allow them to move or, slow down, speed up. For the second law, it is that the force is equal to the mass of a particle or substance times its acceleration. It's a little harder to show that here since we don't have, how heavy the masses are or the exact acceleration each of them are going. But as you can see, the particles are moving in different accelerations depending on how often they are hit or how heavy they are hit. And for the third law, there is every action has an opposite and equal reaction. So in these cases, every action, so like we can see the fast particles moving, they will hit a slower particle and they will either slow down and or speed up. And you have the walls on the side. You can see when they hit the walls, it doesn't really change how quickly or slowly they are moving, because that is a more constant force compared to the particles bumping into each other, which are differently changing.